Hey classes, welcome back. We're going to talk a little bit about where we've been and where we're going and do a little bit of a quick recap before our usual Friday quiz. Remember, quizzes are always open note going forward in here, and make sure you keep a good notebook. And the first grades will go in the grade book also right after the quiz on Friday. I'd said back to school night, and since then that the first grades go in after our first full test, which is tomorrow, because if you have their first one or two assignments, it's always nice to have two or three go in the grade book at once. So let's start. These are some of the silly pictures that were up today. I asked my students not to be too stunned when they saw the incredible graphics from this in the 1980s. This is Carl Sagan, personal hero of mine as a scientist and as a person. And we're going to talk about the sticks that you see and the shadows that they're casting, and how a guy by the name of Eratosthenes, a Greek mathematician, knew the distance around the world 2,000 years ago. Stunningly amazing because he did this with just never leaving his more than about 50 miles from his home, and also with the math that we will know by the end of this school year. And then also, silly memory from childhood where you showed a tiny picture from a Bugs Bunny cartoon when they were supposedly arguing about if the earth was round or flat. We grew up with that as kids sometimes. I'm 56 years old, and when we grew up talking about, the legend like, they thought they were going to sail off the world, we really knew that the world was not flat back then. But we also wanted to talk about Columbus because we just had a super blue moon going on. The students in this class will next see a super blue moon, those two together, not until, their late 20s. Think about that. But when you look at the Columbus thing, we also talked about how his superior knowledge of astronomy enabled him at once to kind of pull one over on the people who were living, the indigenous people who were living in Jamaica, because he knew when the next lunar eclipse was going to happen, and he was able to act as if he was able to have an inside line with God or the gods and take their moon away from them. So that was one of the things that was used by their superior knowledge of astronomy and mathematics. All right, let's go to our first board today and check it on out. We talked a little bit about the light rays hitting the earth, and when you draw something in a textbook, it very often looks like you've got the light rays coming in, you've got the earth here, and the moon on the other side, if you will, and the earth, moon, sun system. You would think, drawn on a flat piece of paper, that the lunar eclipses would be happening every single month. I mean, after all, when the moon is on the opposite side of the earth as compared with the sun, shouldn't the moon be in shadow? Two things we want to talk about there. One, the moon doesn't make a perfect circle around the earth, like this hula hoop right here. Instead, like all things in orbit, ask Kepler about this one, it goes in an ellipse. Now, this isn't a true ellipse when I squeeze it like this. But it makes an ellipse, which is like an elongated circle. That's another one of our math tie-ins. You're going to learn about ellipses over your math classes this year. But the point is, it is then closer to the Earth sometimes and farther away at other times. Those are called apogee and perigee, if you want to know. That won't be on the test, but what is on the test is the way it's set up when we have the Earth, Moon, Sun system and we have a full moon. The moon is on the opposite side of the Earth as compared with the sun. Why don't we get an eclipse every single month? Compared with the sun, the moon does not orbit in the same plane as the plane of orbit of our planet around the sun. It's tilted. This also tied in a little bit with the formation of the moon. The best evidence we have right now is that around 4.5 billion years ago, soon after the formation of the Earth, the young Earth was hit by a planet, they've even named it Theia, by a small planetoid that, when it collided with the young Earth, basically broke some pieces off, and it spread around the planet, forming the moon in a relatively short period of time. Why do we need to know this? It's not just an interesting fact about the way the moon formed, but we're going to talk about the evidence for that. When we learn about atoms, when we learn about radioactive decay, which is critical to this class, because of course we learn about evolution and going back in time, how we know how old things are. One of the things we need to know is, how did they come up with this theory? Turns out they checked out the age of the moon rocks that were brought home by the Apollo missions, and by looking at how old they are, using radiation, what we know about how atoms are put together, we can figure that this is probably the best thing in terms of a theory for how the moon got there. Okay, moving on from there, we talked a little bit about the way in Carl Sagan's little clip where he has the obelisks as sticks and they're trying to figure out the angle of the sun in the sky. He goes across the story about Eratosthenes noticing and writing that at one point, June 21st, longest day of the year, there was basically no shadow that's cast. Your shadow is directly beneath you at noon on the longest day of the year. However, in another town, there was a very definite shadow cast. Now, I've had the good fortune to be able to go to Hawaii twice in my life. Once on my honeymoon 25 years ago, 25 years already, and once with the kids about 6 or 7 years ago. Now, we get off the plane and we finally got outside, and of course, kids were very excited to be in Hawaii. And I said, look, the sun is straight overhead. Look, your shadow is directly beneath your feet. And they're like, yeah, Dad, we just want to go to the beach. But it was a very exciting moment as a science teacher because I was trying to point out to them, this never happens in Pacifica, California. Remember, one of our tie-ins in the environmental studies classes is we're studying longitude and latitude, and we're at 38 degrees north longitude. If this basketball represents the Earth, we are up here at 38 degrees. The sun will get very, very high in our sky. I challenge the students to figure out how high does it get in the sky at the peak of summer and how low is it in the sky at the winter solstice. But the point is, we never have it directly overhead, and that is because, again, we've got our spherical planet. Also, we did use this basketball. It's got Spalding on one side and Warrior symbol on the other side. We use this basketball to talk about how there really is no dark side of the moon. Sorry, there's an awesome album, Dark Side of the Moon, Pink Floyd, 1977-ish, I think. I remember my brother got that album, brought it on home, and I thought, ooh, Dark Side of the Moon, it sounds mysterious. Turns out there's no dark side of the moon. There is, however, a far side of the moon. I walked with this basketball around the classroom. The Spalding here faced towards the classroom the entire time, and that's a little bit like how our moon orbits the Earth. It's in what we call gravitational lock. It's always showing the same face to the Earth. But remember, as the Earth goes around the sun, the moon goes around our Earth. You've got the sun also illuminating what we call the far side. So, sorry, Pink Floyd, there is no dark side of the moon, but there is a far side of the moon. And then finally, one of the last things we talked about in class, and look for the answer on this last one on the line. I took a picture of the chalkboard. Yes, I've got a chalkboard. I've got one in the back of the room. Love that old chalkboard. Reminds me of being a kid at St. Dunstan back in, the 1970s. But one of the things we've been trying to get across is the tie-in between math and science. Remember, you have to have the math to do the science. And especially this week, we've been hitting conversion factors. In your CPM math textbooks, they call it the big one. I think on page 81 of CPM in the 7th grade textbook, they've got a giant 1 over the fraction. And remember, it's the same value on top as on bottom. The fancy name for this is called dimensional analysis. Really want to hit this hard this year. It's one of the most important skills that you need going forward into physics and chemistry in 8th grade and in high school. Last night I had the good fortune to check out my son's back to school night, and listening to the chemistry teacher, they were talking about some of the dimensional analysis that they'll be doing in chemistry class. You're going to need that when you get to high school, because I remember very clearly on a personal note, getting to high school and having never seen that, I really struggled at first with how do you set up the problem. Once you set up the problem, once you set up the math equation correctly, it's a piece of cake. It's a little bit of cross-canceling. I'll make a special video on solving things with dimensional analysis, but I want to keep my videos to the 10-minute limit. So remember, keep your notebook up to date. Tomorrow we have our first full quiz for Friday, and have a fantastic long weekend, everyone. Take care. See you online.